So let's take a look at how the stresses change with theta. Specifically, let's look at how our normal stress changes. So remember, we have our bar that looks like this, and we are cutting at some angle theta from the vertical. And so specifically, let's look at how does normal stress change as our angle's changing. And the question is, when is that going to be maximum? When are we going to maximize our normal stress? Well, let's look at our equation. So our stress is going to be P over A naught cosine squared theta. And so what we have is the theta is what's going to maximize the equation. So where do we maximize cosine squared theta? Well, we'll maximize cosine squared theta when we maximize cosine of theta. And that's at an angle of 0. Because if cosine is 1, cosine of 0 is 1, cosine squared of 0 is also 1. And that should make sense that we're going to have the maximum normal stress when our cut is straight up and down. Once again, you should have been able to maybe even figure that out without having to do the angle thing, because obviously the entire force is going into that. What happens to the shear force at that point? Well, the shear force is going to be 0, because once again, if we go to that equation, one, we can just look at it and see, well, there's absolutely no shearing force. But if we go to our equation, now the cosine of 0 is 1, which is great, but the sine of 0 is 0, so that has the entire equation fall out. Okay, so instead of maximizing the normal stress, where are we going to maximize the shearing stress? Well, that comes now, we are no longer trying to just maximize cosine of theta. We have to maximize both of these together. Where are we going to get to the point where they're the multiplication of the two of them is going to give us the biggest number? And so that's actually going to happen at 45 degrees. So T max, because they're going to be the exact same at that point. So P naught over A theta, sine of 45, cosine of 45. That combination is going to give us the largest number. And it just works out that the combination of sine 45 times cosine of 45 is a half. So our maximum shear stress is going to be that initial load divided by twice the area. So that's a little bit smaller than what our maximum normal stress can be. So at maximum normal stress, shear stress is 0. So the question is, at maximum shear stress, what is our normal stress? So if we go in there and go, okay, well, P over A naught, cosine squared of 45. Well, since sine of 45 and cosine of 45 are the same thing, cosine squared of 45 is also going to be the same thing. So at T max, your normal stress is going to be P over 2 times A theta. So they're going to be equivalent. You're going to see this pop up again in many chapters when we talk about Moore's circle, but this is going to happen quite a bit, where we're going to see that the normal stress at maximum shear stress will equal the shear stress. Shear stress in these contexts will never be more. Okay, so that is just some important information to know about where your normal and shear stresses will be maximized on our oblique planes. If you have any questions, let me know. Otherwise, I'll see you in the next video.